Good morning, students. So waves, and wave still something is there. Still quite a lot is there. Okay, it's not over yet. But basic things we have done. Very basic things about waves. And today we'll see that how much energy and how energy will be transferred. That also we will see. Okay. But before that, let's see what we learned in the previous class. Okay, there are certain questions that we should know about them also. So let's see that. Okay. The first question I am doing from what we did know, velocity of wave in string. From that I am giving. Let's see then how it is. This is a row. Okay. This is a row. Right. In this row, its linear mass density. Its linear mass density is lambda kg per meter. Okay. Now we want to know at this position, which is distance x from the bottom, what is the velocity of wave? In this portion here, what is velocity of wave? Find velocity. Normally, whenever we say velocity of wave in this, they will call it as velocity of disturbance. A disturbance will be created here at the bottom and it will go up. Okay. So, what is the velocity of the disturbance at this position? Find velocity of disturbance at distance x from the bottom of the row. Okay, this is the question. Note first. Then how to do that? What is the formula? Formula is speed is equal to root over t by lambda. This is what we have studied. Okay. So what is tension here? Here only I want that. So what is the tension value here? Who is giving the tension? Tension at this point is given by weight of below portion. Weight of below portion. Now what is the weight of below portion? Mass of this portion into g. And what is the mass of this portion? Very simple. We know that lambda is equal to m by L. But here length is what? X. So x length, right? So lambda equal to mass by x length. So what is the mass? Mass is lambda x. What else? So this portion's mass is lambda x. Put it over here. So this is lambda x, that's mass, into g by lambda. So V equal to what? V is root over xg meter per second. Done? Over. Okay. Velocity at this point is root xg. Okay. Note it. Is it clear? Okay. Note that. Done? Okay. Now in the same question, if they ask us by saying that this length of the rope is L, they say that in how much time our disturbance is going from here to the top. Okay. Find time taken by disturbance to move to the top of rope. Okay, so we have to find how much time it is taking. But in this one, what the problem is? Normally we would have done distance by speed, because speed of the wave so far we have seen is constant. But here it's not constant. Why it's not constant? Because x is not constant. X is position of this point from bottom. Now if this I would have taken over here, then its value is different. Here its value will be different. Right? Speed is different. If suppose this is 2 meter, this is 2, then speed will be what? Root 2g. But if suppose I take it here, where this is 0.5 meter only, then here speed will be what? This is 1 by 2, x will be 1 by 2. So answer will come square root of g by 2. So everywhere speed is different. It's not constant. So I cannot write time equal to distance by speed. Then what to do? Then what is the way? Then the same function you have to write like this. V I am writing as dx by dt. And here is root x as it is. Reason? Because speed is variable. Okay, then dx by root x equal to root g dt. Integration came. Okay, from where to where x value? From 0 to L. 0 to L. 0 here, L here, 0 0 to L in time limits 0 to t. Now integration of this is what? X to the power minus half. So its integration will be what? X to the power minus half plus 1 by minus half plus 1. And we can have the limits 0 to L. And here we all know it's t only. Okay, so here is root g. So what this is? Minus 1 by 2 plus 1. That means 1 by 2. This 2 will go at the top. So it will become 2 and this thing, right? So what's coming? X to the power half, at the top also half by 1 by 2, right? So this we can write as 2 root x. Limits is what? 0 to L equal to root g into t. Okay, put the limit in this, the 2 root L. Okay, 2 root L minus 2 into root 0, that means over, equal to root g and t. So answer is 2 root over L by g equal to t. This is the time taken by the disturbance to reach at the top. Is it clear? Okay, note it. Completed? Okay. Let's see another question. Slightly different than one of the question we did already. Okay, slightly different. Something like this, a wave equation is given. Okay, and the question is asking us, find particle velocity and acceleration at x equal to 0.5 meter at t equal to 0.05 seconds. Okay, note question first. What to do? What to do in this case? He is not asking maximum velocity from us. Maximum velocity would say a omega. He is not asking maximum acceleration. Maximum acceleration omega square a. He is asking particle velocity and acceleration at this position. This position means, if suppose we are talking about rho, then if I am starting it from here, then at this distance, what is the velocity of the point or particle? And what is its acceleration? What to do? Velocity of particle is dy by dt always. So that means we have to differentiate that. Okay, what's going to come? You have to see what's going to come. 0.05 sine will become cos, we know that. What is there inside? This will multiply, this will become what, 5 pi x, and here it will become 20 pi t, and here is minus pi by 4. So sine become cos. Then differentiation of this. Okay, so differentiation of this means this is constant. Okay, we are differentiating with respect to t means x is constant. So this is gone. This is minus 20 pi t. So its differentiation will come as minus 20 pi. And this again is a constant, so leave. Okay, 0.05 sine is cos, remaining all the same. This is 5 pi x, this is 20 pi t. And then here is minus pi by 4. And then differentiation of this results is, we differentiated this is minus 20 pi. Okay, this is velocity of particle. Now what to do? Put x value and t value in that. Whatever is coming, that's velocity. Okay, so let's do 0.05 cos 5 pi into x value is 0.5. 0.5 means 2. 1 by 2. 0.5 means 1 by 2. Minus 20 pi into time. Time is 0.05. 0.05 means 500. Okay. Then minus pi by 4. into 20 pi into 20 pi. Okay, right? Okay. Now this is what here? This is 20 and this is 5. This is 5 and 5 cancelled. This is 0.05 into minus 20 pi cos 5 pi by 2 minus pi. 5 pi by 2 minus pi, and then again minus pi by 4. Okay, so 5 pi by 2 minus pi is 3 pi by 2. 3 pi by 2 minus pi by 4. 3 pi by 2 minus pi by 4. Okay, so what will come? Cos 3 pi by 2 minus pi by 4 is how much? 3 pi by 2 means 270, no? 270 minus 45. 235. 225. Cos 225. Cos 225 means third quadrant. Minus 1 by root 2. Okay. So 0.05 into minus 20 pi into minus 1 by root 2. Please check what I am doing. Okay. Can you do mistake? The 0.05 again I can write as 5 by 100 into, this is all positive now, 20 pi by root 2. So this is 5 again, 5 and 5 cancel. So pi by root 2 is coming positive. This is velocity of particle. Please check, students. Is it correct, students? Students, is it correct? Okay. Now what we have to do? We have to go for acceleration. So for acceleration, what we will do? One more time differentiation of this. Then again, we will be putting the same value. Okay. So what difference is there in this question and the one question we did before? In that one, particle's position along y was given to you, or maximum, it was maximum speed they asked. So maximum speed will be always a omega, and maximum acceleration they asked, that is omega square a. Okay, that we kept. But in this one, what is given? Position along x is given. So you have to use this equation given, and from here you have to find velocity of particle and acceleration of particle, and then you have to keep the value. Okay. So acceleration also we can find it. We can differentiate this one. Right. So if you differentiate acceleration of particle, what's going to come? This 20 into 0.05, that is, how much was there? I forgot. This was 5 by 100 into 20 pi minus. This is 5, this is 5. So minus pi. Okay. So minus pi I am keeping as it is. Then differentiation of cos is what? Minus sign. Remaining all things as it is, 5 pi x minus 20 pi t minus pi by 4. Then differentiation of this again. One more time with respect to t. So that means only this. So that means minus 25. Okay, so minus 20 pi and this pi, it becomes 20 pi square. Then this minus is here. So sine. Now this came what? This all came, I think, 3 pi by 2. No, 225. 225 degrees. 225 degrees means again third quadrant again sign is negative. So minus 1 by root 2. So 20 pi square minus into minus 1 by root 2. So what we are getting? This minus minus gone. This we can write 10 root 2 pi square. Please check, students. Is it fine? Yes, students, is it okay? Okay. Shall we move ahead? Shall we move ahead, students? Okay. See then, one wave is given. Something like this it is. Okay. It's moving along positive x-axis. Its amplitude is given to you as 10 centimeter. Okay. What is the other information? It says at x equal to 10 centimeter, position of particle is 6 centimeters. Okay. And at x equal to 25 centimeter, y value is 8 centimeter. Okay, wave is traveling along x-axis. At x equal to 10 centimeter, position of a particle is 6, and at x equal to 25, position of particle is 8. Let's say find wavelength of wave. Find wavelength of wave. Note information first. Okay, done? What to do? This is how the wave is. Starting from 0, let's say at x equal to 0 and t equal to 0, something like this. It is starting like this. That means initial phase is not there. Okay. I am not taking initial phase. Okay. Then what is given? At x, this much, y is this. So first of all, let's write wave equation. What wave equation we are taking? We are saying, okay, wave equation is a sine kx minus omega. Seeing the shape of the wave, we are taking it as kx minus omega t, and initial phase we have taken 0. Okay. So, if I write for this, he says y is 6 centimeter here, this is 10, is sine k, x value is given 0.1 minus omega t. Okay. Then this value is also there. Write as 8, 10 sine k, now 25 centimeters. So 0.25, or we can write it in centimeters only. There's no need to write it in 0.1 like that. We can put it in centimeters. So here is 10 and here is 25 minus omega t. Now what we can do? This is the given information, everything we have done. Okay? Everything we have noted. Now what to do? Okay, from first equation I can write this as 6 by 10 equal to sine 10k minus omega t. 6 by 10 means 3 by 5. Sine inverse 3 by 5. Sine inverse 3 by 5 means 37. Is it? Yes or no? Sine inverse 3 by 5 means 37 degrees. Okay. This is 37 degrees. 37 degree equal to 10k minus omega t. Fine. Same way this also we can do. 8 by 10. 8 by 10 means 4 by 5. 4 by 5 means 53 degrees. So this is 53 degrees is equal to 25k minus omega t. Right or not? This we got 10k minus omega t. Now from how we can get the lambda value? From here. Okay. This is our first equation. This is second equation. So first is degrees we will convert into radian. Okay. First degrees we will convert into radian and then we will solve it. So first note this one. Note. Completed students? Yes. Okay, now tell me what to do. First convert this in radian. Okay. So 37 into pi by 180. 36 I have written. 37 pi by 180 and here is 53 into pi by 180. Now what you can do? You can subtract 10k minus omega t and here is 25k minus omega. Just solve it as linear equations. Okay, this will cancel omega t. Then you get k value and k value is 2 pi by lambda. We know that. Okay, come on, do that and tell me what is the answer. What's the answer, students? What is lambda value? Check. Are you getting the same answer? Students, are you getting same answer? Okay. So 45 into 7.5 centimeter, whatever that is. That's our answer. Okay. Let's move ahead. If you have done, let's move ahead. Hmm? Completed, students? Everyone? Okay. Okay, note it. Done? Shall we go ahead now? Okay. What next? Simple question. A wave is given in this way. Not wave is given, this is a photograph at any instant. Okay. Snap of a wave is taken like this. Okay. What are the informations regarding this? It says that amplitude is 2 centimeters. Okay. And this snap is taken at 0.3 centimeter or 0.3 seconds. Okay. And this distance is 1.2 centimeter. Okay. Time is 0.3 second. This distance is 1.2 centimeter. And crust P was at x equal to 0 at t equal to 0. This P was here at t equal to 0. Okay. Write equation of wave. Write equation of wave. Write equation of wave. Any information missed, we'll see that. If any information is missing, we'll take it. Okay. question first. Done? Okay, see what we can do. First of all, what informations are given in the question, that we have to identify. What's given? He says this point P was here at t equal to 0. So it has moved to this. How much? 1.2 centimeter. In how much time? 0.3 seconds. So that means we have velocity of wave. Wave has moved because disturbance has moved 1.2 centimeter in 0.3 seconds. So we have speed of wave. Okay? Speed of wave. What is it? Distance moved by disturbance by time. Distance moved by crest by time. 1.2 and 0.3, that is 4 centimeters. Speed we have, amplitude is given. So anytime if we write equation by seeing it, if it is this form, then what is given to me? A I have, speed I have. Okay, A I have, speed I have, but wavelength is not there and frequency also not there. So wavelength we will take. Okay, take wavelength as 7.5 centimeter. Okay, wavelength information given to you in the question itself. Okay, wavelength is given. Now what's left? Omega. How to get it? We know speed equal to frequency into wavelength. Okay, the wavelength is given, speed we have. So definitely we can find frequency also. Let's see. So speed equal to frequency into wavelength. Speed is 4 and wavelength is 7.5. 7.5 means 15 by 2. So 15 by 2. So frequency is 8 by 15. So frequency also we have. Okay. Now we have to see whether this sine function is correct or not correct. Initial phase is there or not there? Initial phase is there. He says that when this wave started at t equal to 0, is it starting from mean position? No. He said that crust was here. That means it was starting like this. Starting like this at t equal to 0. This is not sine. Or initial phase is not 0. Then what is initial phase? Initial phase is 90 degrees. Okay. If a wave starts from mean position, then initial phase is 0. But if wave is starting from extreme, that is extreme because it's starting from amplitude. Okay. So mean position 0 phase, extreme position 90. Then again when you are coming back to mean position, then phase is 180. Then you go that side to extreme, phase is 270. Then you are again coming to mean position means you can say 0 or 2 pi, your wish. Okay. So here it is. Here it would have been 0, but it's starting from here. So what is initial phase? 90. So here kx minus omega t only will not do. It will be plus 90. So what is wave equation now then? A cos kx minus omega t. Okay, now put the values. This is what? 2 cos, okay, k value we have, that's 2 pi by lambda, lambda value we have, so 2 pi by lambda value is, where is lambda? Lambda is 7.5, okay. So you can put here 15 and here you can put 2. So 15 by 2 minus 2 pi into frequency, what is frequency? 8 by 15. So 8 by 15 into t. This is the wave equation. So 2 cos 4 pi by 15 into x, I forgot to write x here, right? 4 pi x by 15 minus 16 pi t by 15. This is your wave equation. Is it clear?
Yes, sir.
Okay, note that. Completed?
Yes, sir.
Okay. See another one. Okay, so here is, let's assume this is 0.2 and this here is 0.06 and speed is 300 meter per second. Snap is taken at t equal to 0. Okay, write equation of wave. Write equation of wave. we can show similar one, right? Okay, leave it. That is what you have to find from the given data. Check, it is there. In given data only it is there. Check, are you able to find? See, this is one wavelength. This is lambda. This is another one. It's lambda. And this is half wavelength. Okay. Lambda plus lambda by 2 equal to 0.2 meter. So 5 lambda by 2 is 0.2. So lambda equal to 0.4 by 5 meter. Okay, so 0.4 into 100, that is 40 by 5, that is 8 centimeter. Okay, so that's lambda. Then what else you can do? Omega also we can find. V is given. So V equal to frequency into wavelength. So frequency is equal to 300 by 0.4 by 5 or 8 centimeter, whatever you want. Okay, you can keep it in that way. How much is coming? 15,000 by 4. Okay, 3750 hertz. Now nothing is there in it. Okay. At t equal to 0, it's starting from mean position only. So there is no problem to us. So a sine kx minus omega t. Let's put the value. This is 0.06 meter sine k value. K value is 2 pi by lambda. Lambda is this 2 pi by 0.4 into 5 x minus 2 pi into frequency 3750 into t. That's it. Clear? Students, is it clear? Completed? Completed, students? Yes, students, shall we move ahead?
Yes, sir.
Okay. Now, one question I am asking you from the old concept. Find path difference between two particles of a wave of wavelength lambda having phase difference 60 degrees. Come on, I am expecting its answer from you. Yes, students, who is going to give me the answer?
5/6.
5/6. Okay, 5/6 or 5/6?
5/5.
Pi. Okay. Anyone else? Path difference he is asking, phase difference he has given. You should have the relation, right? We have studied. We don't know this relation. You have studied this in wave optics, no? What is phase difference? 60 degrees. 60 degrees means pi by 3. 2 pi by lambda into delta x. Pi and pi gets cancelled. So, it's lambda by 6 is the path difference. Is it clear? Students, is it clear?
Yes.
Note that. Done? Okay. Another one. Similar. It says frequency of a traveling wave is 40 hertz. Find change of phase in a particle at any place in 0.2 seconds. Change of phase in a particle at any place in 0.2 seconds. What to do? Here there is no talk about lambda. Okay, no talk about lambda, nothing is given. Time is given, frequency is given. What to do? Here he is talking about a single particle. Phase in a particle at any place. That means x is constant. So here delta phi is not k delta x. In the previous question, what was the difference? Find path difference between two particles. Okay, one particle may be, this is the wave. One particle may be here, another particle may be here. Possible. But in this question, he is asking about single particle only. Maybe this particle. Now what this is doing? This is doing simple harmonic motion. So its place is changing, but its place is changing because of time. Okay, so phase will change because of time. So in this case, delta phi is not k delta x, it is omega delta t. Because x is same. Actually phase is what? Kx minus omega t. No? So what is difference here? First case kx minus omega t1 minus kx minus omega t. Kx cancelled because x is same. So what we got? Omega delta t. In the previous case, time was same time. So omega t cancelled. So we got k delta x. Here omega delta t because kx is same. Okay. So here answer is this. So delta phi will be 2 pi into 40 hertz into delta t is what? 0.2. 16 pi is coming. Is it clear? Is it clear, students? Is it clear?
Yes, sir.
Okay. Completed, students? Yes, students completed.
Yes, sir.
Okay. Now let's talk about energy. Energy carried by wave and string. So what we know in this? We know that every particle is doing SHM, right? So if every particle is doing SHM, then energy also will be associated with what energy is associated in SHM. There is half m omega square a square. Okay, we know that it's kinetic energy and potential energy. They keep on changing in each other when the particle do SHM. But the total energy is constant only. So that's half m omega square a square, we can say. In a wave, all the particles are doing SHM. So if I say that every particle's energy, whatever be the mass of every particle, okay, dm or whatever, okay, every particle's energy will be that same only half dm omega square a square, because everyone is doing with the same frequency, with the same amplitude. Every particle in a wave is doing same kind of SHM, okay, same frequency, same amplitude, but only difference is like everyone is not at the same position all the time. Everyone is at a different position. One is going up, other one is going up, down, like this. Everyone will be in different positions. But every particle is having same energy. So if total mass is m, then we can say that the energy is half m omega square a square. Correct or not? Energy will be half m omega square a square for maybe all the particles which are oscillating, right? So energy of wave, we can say what? It is half m omega square a square. Correct? But we don't take it in this form. We have to change the form. What form we take? First thing is we talk about energy density. Energy density means what? Energy per unit volume. Okay, let's go into energy density. This is energy density. This energy, how we represent this energy density? With U, small u. This energy of wave per unit volume. Per unit volume means what will happen? It's half m by v omega square a square. Now m by v is what? Density. So you'll write this as half rho. This energy density, half rho omega square a square. Fine. This is energy density. Then we'll talk about power. Okay. Power transfer. Power transfer means what? Energy per unit time. Okay. So power P, and this is what? Energy transferred per unit time. Now energy transferred, shall I go back to this? No. In terms of rho only. In terms of rho, then energy transferred, what we have to do? This into volume. This into volume. What we'll do? Let's see. Half rho omega square a square. Okay, then area into length. Area into length. Like you can consider like a cylinder, no? What we do in that, base area into length is the volume. Exactly same way. Okay. So area, I am taking area as S into length by time. Time is there. Length by time we write as velocity. So change here, change will come here, half rho omega square a square s into velocity. This is velocity of wave, okay, and s is area, remember. This is power. Why we are doing all this? To find intensity, because we have maximum work with intensity. You have seen in wave optics, okay, we talk about intensity most of the time. So we have to get intensity. First note this one, then we'll find the intensity of this, okay, note it. Completed?
Yes. Yes, sir.
Okay. Right. So let's talk about intensity then. Intensity is what? Intensity is power by area. Power transferred by area. Power is what? Half rho omega square a square s into v by area. This is s. So what are we getting? Half rho omega square a square into velocity. In this one, what are constants? Rho constant, omega constant, v constant. So that's why we used to write intensity is directly proportional to amplitude square. This is what you have studied. Intensity is proportional to a square, and this is intensity. Okay, note this. Then completed students.
Yes, sir.
Intensity unit watt per meter square. Remember. Okay. Now I'm going back. This energy of wave that you have written, this energy of wave is kinetic energy, potential energy, or both? Both. Average of both. Then how much is kinetic energy? Half of this. How much is potential energy? Half of this. Average kinetic energy average potential energy okay, 1 by 4 m omega square a square, 1 by 4 m omega square a square. Kinetic and potential energy average is same. You add, you are getting half m omega square a square. That's average energy. Is it clear?
Yes, sir.
Note that. Okay. So now this is a wave in string. Okay. This is point A, this is point B. Okay. You have to tell me among A and B where kinetic energy is maximum, where potential energy is maximum. Okay. At what position kinetic energy is maximum and at what position potential energy is maximum. Come on. Yes, students. Where kinetic energy will be maximum? Yeah. Yes, Akhilesh.
Point is
Point A, what is maximum?
the kinetic energy.
At point A, kinetic energy is maximum. Okay. Yes, Akhilesh, what about you?
Sir, B.
At B, kinetic energy is maximum. Okay. All right. What about potential energy? Potential energy is maximum at A. Okay. Girls? What's your answer? Yes, Shweta, what's your answer?
The kinetic energy is maximum at option C, point B, sir.
Okay.
Potential energy is maximum at point A, sir.
Okay. Potential energy maximum at A and kinetic energy maximum at B. All right. Okay. Anybody with a different answer? Yes, Ashini, what's your answer?
So the same, sir. Kinetic energy is maximum B and potential energy.
Okay. Okay. So kinetic energy is associated with the particle. Particle is doing SHM. Okay. Particle is doing SHM. And maximum speed a particle is having is at mean position and not at extreme. A is extreme. This is extreme. Here speed of particle is 0. So kinetic energy at A is 0. When A will come over here, then it will have maximum kinetic energy. But at the moment, its kinetic energy is 0. So we don't have this as the answer. Kinetic energy at B is correct. Kinetic energy is B and B is correct answer. Okay, fine. This is kinetic energy. Now what about potential energy? Now potential energy in wave in string particularly, is it maximum over here? Answer is no. Potential energy is maximum at a place where stretch in the string is maximum. Okay. Because potential energy for what? This is not potential energy of the particle. This is potential energy of the string, because string is actually transferring the energy. Okay. Remember that. Kinetic energy is with the particle, but potential energy with the string. Okay. So potential energy is maximum where string is stretched maximum. Now question is, how do I find the stretch? See how we are going to find. Now I am going to tell you, after that you will be knowing anyhow, right? Okay, see then. Okay, now what then? Just see. Suppose at point A and point B, 2 points only we have for comparison, right? So suppose here I am taking one small distance. See how I am trying to explain it. Let's see, I hope you understand that. Because this is delta x, okay? Same delta x I will be taking here also. Same, okay? See. Okay, one more. Right. I hope it's same, okay? This is also delta x. Now you tell me, in both delta x, in which one length of string is more, at point A or point B? See and tell me, in which one length of string is more? Tell me no. This is the length of string in B. This is. And this is the length of string in A. Which is more? At point A it is more or point B it is more?
Point B.
Point B it is more. Okay. It's like a spring. Okay. In spring, potential energy means how much is the extension. Okay. At A, extension is very less. At point B, extension is more. So potential energy is also maximum at B. Waves in string. Remember that. Is it clear?
Yes.
Note it. Always remember, when we talk about waves in string, it is not about particles' kinetic energies converting into particles' potential energy. No. It is particles' kinetic energy and potential energy associated with the change in length of string. Where stretch is there? Here there almost no stretch. Whatever is the length over here, almost is the length over here at the top. So that means hardly any change in length. But here you see, actual length is this much, but now it has become this. So stretch is there. When stretch is there, that means potential energy is there. So here is potential energy. When you talk about wave in string, it is about potential energy of string, not about the particle oscillating. That is only the difference. Okay? Note it. So what is the different thing? Kinetic energy as well as potential energy, both are maximum at B, and at A, both are 0. Potential energy also 0 at A, kinetic energy also 0 at A. Okay? Clear? Okay. So that's it, student, for today. This much only. We'll see in the next class then. Okay? Reflection and transmission in next class. Alright? See you then. Bye bye.
Thank you.